Okay, in this video we're going to cover 7.4, which are vectors. Vectors are quantities that describe both the magnitude and direction. Magnitude is going to be the length of the line segment. Magnitude is going to be the length of the line segment. When we're looking at magnitude, it is defined by this symbol here. The vector itself is going to have an initiating point, which is P, and then the terminating point, which is Q. So I'm going to say initiating point is where it starts, and then the terminating point is the arrow or where it ends up. Okay? The length of that vector is called the magnitude. Two vectors are equal if they have the same magnitude and direction. Number 1 says determine if the two vectors are equal. We're going to start by plotting the first one. This is the initial point, which is -3, +1. 1, 2, 3, up 1. There's my little dot, initial point, 2, 1, 4. So 1, 1, 2, 3, 4. This is going to be my arrow, and then I'm going to go ahead and draw the line. And we're going to call this V. Okay. W starts at 0, -3. So here's my 0, 1, 2, 3. There's my initial point. My terminal point is 4, 0. So 1, 2, 3, 4. This is going to be my arrow. Okay. This is going to be W. So for us to determine if these two are equal, they need to be in the same direction, which they are, and let's see if they're in the same size. So the way I normally do it is I start at the initial point and I count how many it takes to go across and then either up or down. So we're going forward 1, 2, 3, 4, and then we're going up 1, 2, 3. Forward 4, 1, 2, 3, 4, yes. Up 3, 1, 2, 3, yes. So yes, these two are equal. The second one says -4, -2, 1, 2, 3, 4, down 2. Here's my initial point. And then -1, -4. So -1, 1, 2, 3, 4. Here's my arrow. Okay, so let's do this one. And this is going to be A. Okay. B is 4, 2. So 1, 2, 3, 4. Up 2. There's my initial point. And then 1, 4. So 1, 1, 2, 3, 4. Here's my arrow. And automatically I can see these are in opposite directions, so it doesn't matter if they're the same size. The answer will be no, because they can only be equal if both magnitude and direction are the same. So on this page, what we're doing is we're adding vectors, and the way that we're going to do that is going from tip to tail. So here's the tip, there's the tail. Tip, tail. And when we do add them, we're going to go from the tip to the tail. If you're doing it by a negative, what you're saying is you're just changing the direction. So for example, in this case, you have a W going this way. Well, a negative W would be the same size, but in the opposite direction. And then we can go ahead and subtract. Now, subtracting vectors is similar to adding it, but you're in the opposite direction. Okay, so there's a couple of ways that we can do this. The other thing we have is multipliers or scalars. Scalars are going to be the number in front of the vector. So here if I say, here's my unit vector V, and if I go twice that vector V, it means the length is going to be twice as long, half as long as the original vector. Okay. The negative means it goes in the opposite direction. Let's go ahead and look at number 2. Number 2 says, sketch by placing the initial point of U at the terminal point of V. So the terminal point of V is going to be here. This is where it ends. So I'm going to put the initial point of U, it's going to be right here. Okay. Now let's go ahead and find out where U is. So U is going to be down 1, 2, 3, right 1, 2, 3. So 3 and 3. 1, 2, 3, 1, 2, 3. Here's going to be the terminal point. So this is what our U is going to be. Okay. Next thing I'm going to do is add them. I'm going to go from the tip to the tail. So from here straight to the tail. This part right here is going to be U plus V. Number 3, we're going to sketch U plus V by drawing U and V with the same initial points. So in this case, what I'm going to do is they're both going to have the exact same point. So I'm going to move my U over here to the V. So let's count the size. Down 1, 2, 3, 4, 5, 6, 7, 8. And then right 1, 2, 3. So down 8, right 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Here's going to be my terminal point, my arrow. Okay, so here's going to be my U. Okay, and here's my V. Now, in order for us to add this, what I'm going to have to do is translate my V over here as well. Because remember, we don't want the same initial point. We just want to go ahead and translate one of these to be from tip to tail, tip to tail. Okay, so let's go ahead and find out where my V is. My V is going to be 1, 2, 3, 4 down, 1, 2, 3, 4, 5, 6, 7 across. So 4 down, 1, 2, 3, 4 down, and then 7 across, 1, 2, 3, 4, 5, 6, 7. So it'll be a little bit off the page right there. Okay, so this is going to be my V. So from initial point to terminal point, from tip to tail, this is going to be my U plus V. Number 4, we're going to do subtraction, and we're going to have the same initial point. So I'm going to move my vector W up here. So let's find out the size. We have 1, 2, 3, 4 going down, 1, 2 going forward. 1, 2, 3, 4, 2 going forward. Here's going to be my terminal point, which is there. Okay. When we subtract these, they can have the same initial point, and then all I'm going to do is go from the terminal point to the terminal point, and we're going to have V minus W. It's going to point to V, to vector V. For number 5, what we're going to do is we're going to sketch these two vectors in standard position. Standard position is going to mean the origin. So the very first thing that I'm going to do is find out what the size of, let's start with V. V is going to be going 1, 2, 3 down, 3 down, and we're going 2 back. That is the original vector. But now we're going to multiply by -2. Well, 3 times 2 means we're going to have 6, and then we're going to go opposite. So instead of going down, we're actually going to go up. Okay? And then we're going to go 2 back, multiply that by -2. That means we're going to go 2 times 2 is 4, and instead of going back, we're going to go forward. Okay, so let's plot that. 4 forward, and then 6 up. My terminal point would be right here. And this I'm going to label -2V. Okay, now let's do 3W. Let's find out what that is. 2 forward, and I'm going up 2. 2 up. Okay. If I'm multiplying it by 3, I'm going to be going 6 up, and I'm going to be going 6 forward. Okay, so let's do that. 6 forward, 6 up, right here, and this is going to be my 3W in standard position. The next part here is talking about representing vectors in component form. Now, when you're given your initial point and your terminating point, we can translate that to a vector or the size. If you look on your reference sheet, you will see those formulas are located right here. Okay, so you have those. I'm going to label this my initial point as x1 and y1, and my terminating point is x2, y2. Now let's just use the formula. Vector V is equal to x2, negative 1, minus x1, 3. y2, which is 3, minus y1, which is 8. Okay? Simplify. Negative 1 minus 3, that's going to be negative 4. And 3 minus 8, that will be negative 5. And that's your answer. Number 7 says, find the vector, initial, terminating, same equation. Let's start with x1, y1, x2, y2. So v is going to be equal to negative 20 minus 12, comma, 10, minus negative 10. Okay. Negative 20 minus 12, that will get us as negative 32. And 10 plus 10 will give me a 20. So this will be our answer for number 7. Now, the second part of 7 says if V is placed at an initial point of 5, 3, in other words, this is not the initial point, this is going to be our new initial point, where would the terminal point be? Well, all we're going to do is subtract 32 from X and then add 20 to Y. So we're going to go ahead and do V would equal 5 minus 32, 3 plus 20. 5 minus 32, negative 27. 3 plus 20, that's 23. And this is going to be our answer. On this page, what we're talking about is the equality of vectors. These two vectors will only equal each other if the corresponding A for each of them are exactly the same, and the corresponding B for each of them are exactly the same. Okay, so on the second part here, we can add vectors together by adding the A's together and the B's together. We can do subtraction by subtracting the A's and subtracting the B's. And then we can multiply by a scalar by multiplying whatever constant we have to both the A and the B. Okay, here are a bunch of other properties. So these are essentially the properties of vectors. Let's go ahead and do a few. First thing I'm going to do is I'm going to add two vectors together. I'm going to add R and S. So all we're going to do is add our A's together and our B's together. Okay, so number 8 is going to be equal to 1 plus 2, comma, negative 4 plus 3. 3 minus 1. This is our answer for number 8. Number 9, we're going to multiply our vector S by negative 4. So all I'm going to do is multiply negative 4 to each of those values. So negative 4 times 2 is negative 8. Negative 4 times 3 is negative 12. That's our answer for number 9. Number 10, you can see we're doing something a little different. We're multiplying each of the vectors by a different scalar. So let's start with the 3R. I'm going to multiply everything in R by 3. So I'm going to have 3R is equal to 3 times 1 is 3. 3 times negative 4 is negative 12. Plus 2S. So I'm going to multiply S by 2. 2 times 2 is 4, comma, 2 times 3 is 6. Now what I'm going to do is I'm going to add the A's together and add the B's together. So 3 plus 4 is going to be 7. Negative 12 plus 6 is going to be negative 6. So this is going to be your answer for number 10. On this part here, what we're talking about is when we represent vectors in terms of I and J. So what we're essentially doing is adding an I after the A and a J after the B. We'll do a few examples of this as well. Magnitude formula is here. That's also given on your formula sheet, located right here. Number 11, it says find the unit vector of W. Okay, on this part here, we're looking at a unit vector. A unit vector is a magnitude of 1. Just like our unit circle, we have a radius of 1. Our unit vector will be a magnitude of 1. Okay. So in order for us to find our unit vector, all we're basically doing is doing whatever we get for A and dividing it by the magnitude. and then whatever we get for b and dividing it by the magnitude. We're going to go ahead and do this one here. First thing we need to do is find the magnitude of w. So I'm going to start with that. So the magnitude of w, and then plug in the formula, is equal to the square root a, which is in this case going to be -8 squared, plus b, which is 15, and we're going to square that. Okay, let's use our calculator. Okay, I went ahead and put it in the calculator. Notice I don't have the square root yet, but I put in the -8 in parentheses. If you don't have this in parentheses, you're going to get the wrong answer because the square needs to be applied to the negative as well. Press enter, I get 289, and then I'm going to do second square root, second answer, and then I'm applying the square root value, and I get my answer to be 17. So now I have my magnitude to be 17. So the unit vector of w is going to be a, which is -8, divided by the magnitude of w, which is 17. b, 15, divided by the magnitude, which is 17. This is going to be our unit vector. Okay? And then finally, what we're doing is we're going to represent our vector in this terms, in terms of a and b, into terms of I and j. We would write it like this. V is equal to a followed by an I plus or minus, depending on what b is, followed by a j. Okay? So let's go ahead and write this. I'm going to start with my a, which is -12. I. Now remember, I is going to be a vector, so I need to actually use my little arrow sign. Minus 30, j, also a vector. All right. And that concludes 7.4. Let me know if you have any questions.